When I spoke to Frank Buchholz at Microsoft recently, he was talking a lot about running AI locally on Surface. And I'll be honest, at the time it felt a bit out of reach. It was interesting, but pretty nerdy. Not something that most people are realistically going to do, but it stuck with me, so I decided to try it, being a nerd. Not to build something complex, just to see if I could get anything working at all on the NPU of a Copilot+ PC, and whether it was actually practical to do. So I built a simple app, an AI language model chatbot, one question, two answers, one question coming from an AI model running right there on the device, one from the cloud. And I wanted to see if an AI language model could really run on a Copilot+ PC. And this is where Frank's work was really important because he did the pre-work that makes all of this surprisingly easy. In our last video from when I was in Redmond, Frank and I sat down and talked through what he'd built, an app running entirely on the Copilot+ PC's NPU, no cloud, no connectivity. What stood out to me wasn't just the demo, it was how he explained it. Not just look at this cool thing that we built, but as a way of thinking about AI differently, thinking locally, and why you might want to do this at times. Now here's the short version. Frank's not a software developer by trade, but he built a working AI application that really takes advantage of the NPU on his Copilot+ PC. Now, when I first saw that, I thought, that's impressive, but it does still feel a bit out of reach. Now, here's the really clever part. Frank wrote a blog post about this, and that blog post is designed not so much for human reading, but it's designed for an AI coding assistant. You can simply copy the URL for the page into your coding app, Claude Code, GitHub Copilot, Cursor, whatever you prefer, and it digests all the technical stuff that you need to build an app like this. Then you tell it what you want, and it builds it. That's the workflow. Now, I'm not a developer, but I know enough to try this out, so I did, and it worked. Before I get into the build, I want to acknowledge that this video is sponsored by Intel. I'm running this demo on the latest Intel-powered Surface Copilot+ PCs, the Surface Laptop and Surface Pro for Business, which are powered by Intel Core Ultra Series 2 processors. And these chips deliver something like 48 TOPS of NPU performance, which is what earns them the Copilot+ PC designation. More on why those numbers matter in a moment. So if you've bought a new laptop in the last year or so, there's a good chance that it has an NPU in it, a neural processing unit. Think of it as a third type of processor inside a computer chip alongside of the CPU and the GPU. But this one's purpose-built for things like pattern recognition, language processing, and image classification. The Copilot+ PC benchmark is 40 TOPS. That's 40 trillion operations per second, dedicated to AI tasks on the NPU alone. Every current Surface device hits that mark or exceeds it. Still, you wouldn't be alone if you thought that 40 TOPS meant absolutely nothing to you. That's why testing it out was on my radar. Windows has already been using the NPU, but in ways you probably wouldn't notice too much. Windows Studio effects, the background blur on your camera, voice focus on your mic, eye contact correction, that's the kind of thing that's running right now on the NPU. The Windows 11 Live Captions app with real-time translation into 44 languages uses it. Fluid dictation for voice typing in Windows 11 too, that works on the NPU. But the NPU is not just there because it can do those things. It's there because it can do those things more efficiently, using less power and generating far less heat than a CPU or a GPU would. But those are features that Microsoft built for you. The question that Frank's blog post asks, and the question I wanted to answer is, could you build your own? So here's what I decided to build. A single question app. You type the question in once, and it sends the same question to two places. First, a small language model running locally on the NPU. In my case, Microsoft's Phi 3.5 Mini. Think of it like the model behind ChatGPT, but made really small so that it can fit on my device. And second, a cloud large language model, but one that was simple and comparable. I used Google's Gemini Lite for the sake of this comparison because I could get it to work with my app really easily. Then it shows the two responses side by side. So the same question, but two environments. Nothing too complex, but it was revealing. The idea wasn't to build a product, it was to answer a question. Would it even be possible to use a local AI language tool instead of the cloud? And I built it the same way Frank describes in his post. I pointed Claude Code at his article, which described what I wanted, and I let it generate the structure. Then I asked for some changes. I found a cloud language model that let me call it using an API, one that didn't cost too much for the demo. I locked in on Google's Gemini Lite for the test. I had to go through a few tries before I found something that worked. I added a token comparison calculator so that I could compare the cost of using the NPU versus the cloud, and I got it to fix some display issues. That loop, describe, run, fix, is exactly what Frank talks about in his blog post. You might hear it called vibe coding. This was a test of the hardware as much as the model, so what actually happened? Well, the cloud response, it took a minute to get started, but it finished fast. It gave a really polished answer. It's exactly what you'd expect. The local model did behave differently. It started responding almost immediately, but it took longer to complete. The answers were typically shorter. But the quality, genuinely impressive for something that was running entirely on the device. Not perfect, not as strong as the cloud, but definitely usable. And it did that without touching the network. It runs entirely locally. And that's when my thinking shifted. Because I had this filed under interesting but not practical, but that's not where I'd put it anymore. Now, running a language model on your device will not match what you can do in the cloud. But what if you want to take advantage of the amazing language capabilities that we have in large language models, but the information that you're working with cannot leave your network? I work with government customers. I work with organizations that handle sensitive information, health records, defense documents, citizen data. For many of these customers, sending data to a cloud API isn't an option. Not because the cloud isn't secure, it often is, but because policy, regulation, or classification levels simply don't allow it. But local AI can do it. And what if you're collecting data in a remote location where internet connectivity is just not great? Believe it or not, here in Australia, we have a lot of places like that. And in that situation, you could hand the job off to a local language model running right there on your device. Get an answer, but without connectivity. If you have an NPU, you can do that without the massive overhead and power usage that comes with large language AI tools. So you can do it on battery for hours. And there is no token cost. Even the model is free. So it's entirely free to do this. If I was a software developer wanting to put AI features into my app, given the cost of using AI tokens in the cloud, I would seriously consider this as an option. So what's the Intel-powered Surface Pro actually like? Now, I should be upfront, my daily drivers are the Qualcomm-based Surface Pro models. I love them. All-day battery, instant on, they just have a great tablet feel. There are a lot of small improvements that Qualcomm have brought to the game with the Snapdragon, like camera quality and wake-from-sleep reliability. So picking up the Intel Pro for business, the question isn't, is it better? It's what's different and who's this for? Physically, it's the same beautiful hardware, same display, same kickstand, same accessories. You can't really tell them apart. Same for the laptop. Where the Intel model really shows its hand is compatibility. This is x86. Every Windows application, every print driver, every legacy enterprise tool runs natively with no emulation. If you're deploying in an enterprise environment with specific line of business apps, then the Intel model removes that conversation entirely. You also get Thunderbolt 4 on both USB-C ports, which my Qualcomm models don't have. And that's meaningful if you're docking into a multi-monitor setup or you have high-speed external storage. The trade-off? Well, Qualcomm has driven innovation with its Snapdragon processors. As I said, better camera systems, better sound, better battery life. And while compatibility limitations are not what they used to be, there are still limits to Qualcomm's ARM-based processor architecture. So if you need guaranteed compatibility across your entire app stack, then the Intel Surface Pro for business is the one to buy. But the fact that Surface gives you both options in the same form factor just extends the possibilities. Thanks for watching, and we'll see you in the next one.